Good morning, students. Welcome to Mathematics 8, Quarter 4, Week 6. And by the way, my name is Viola Roland Jr., your subject teacher in mathematics. So, our topic this morning is counting the number of occurrences of an outcome using table, tree, diagram, and systematic listing. Have you ever heard a barista from Starbucks Coffee claiming that they have 85,000 combinations of coffee to enjoy with? You can add caramel, a squirt of ice cream, and vanilla instead of chocolate. When a company had this claim, they are using different variations on their favorite drinks or different ways to serve their coffee. This company uses a table, a tree diagram, or systematic listing to make this claim. Example, when you toss a coin, there are two possible outcomes, head or tail. List all the possible outcomes and how many possible outcomes are there for the experiment of tossing two coins, a 1 peso coin and a 5 peso coin. So for our solution, these are the list of possible outcomes for the experiment shown in the table. Aside from using table, you can use a tree diagram to help you find the possible outcome using branches to list choices. It is a simple way to represent the sequence of events. So this is an example of a tree diagram. Listing all the possible outcomes, we have head, head, tail, head, tail, tail. There are four total number of possible outcomes. Example number 2, use systematic listing in writing all the possible outcomes for the experiment in rolling a die. Determine the total number of outcomes. So in solution, in rolling a die, we have 6 possible outcomes. So these are 1, 2, 3, 4, 5, and 6. Example number 3, list all the possible outcomes and determine the total number of outcomes when a die is rolled and a coin is tossed. So by systematic listing, the possible outcomes are, so these are the possible outcomes: the head, one tail, two head, two tail, three head, three tail, four tail, five tail, six head, six tail. The total number of outcomes rather is 12. And we have also the using the tree diagram. Number 4, example number 4, Natalie is ordering a milk tea. She could have a small, medium, or large milk tea. She has a choice of winter melon, Okinawa, or salted caramel. How many different choices of milk tea can she have? So, solution, make a tree diagram to show all the possible outcomes. So, we have here the tree diagram. So, these are the possible outcomes using the tree diagram. So accordingly, there are 9 different choices of milk tea. The fundamental principle of counting. Let us say you want to go on a shopping, you are looking for a new dress, you want to have a new lady shirt, skirt, and sneaker. It is so happen that you have your favorite department store has a sale and offers 1,000 for a blouse, skirt, and sneakers combo. The lady shirt that you like has 6 different colors. The skirt that you love has 4 different styles. And the sneakers has 5 awesome design. How many different outfits combinations are possible? You can use degree diagram, listing method, or table, but the best way to answer this is using the fundamental principle of counting. So when we say the fundamental principle of counting states that it is one thing can occur in m ways, and second thing can occur in n ways, and third thing can occur in p ways, and so on. Then the sequence of things can be occurred in m times n times p ways. So, how many three digits number can form in a number 1 to 9 if repetition of the digit is not allowed? If repetition of the digit is allowed, so solution, we can use the box method to represent the 5 digits. So we can put number 9 in the first box, then 8 in the second box, and 7 in the third box. But since repetition of the digit is not allowed, so in here we have 504 repetition is not allowed. And the second one is 729 repetition is allowed. Example number 2, in how many ways can a clown distribute 8 balloons in 6 different children? If each child gets one balloon, there are 8 choices for the first child, 7 choices for the second child, and 6 choices for the third child, and 5 choices to the fourth child, and 4 choices for the fifth child, and 3 choices for the sixth child. Therefore, 8 times 7 times 6 times 5 times 4 times 3 is 20. It's also 20. And there are 160 ways. Example number 3, there are 12 doors to a room. In how many ways can a person enter one door and leave by a different door? Solution, 12 choices to enter and 11 choices to exit. Therefore, 12 times 11 is equals to 132 ways. So, and there are lots of examples. So, just simply read these examples and then just simply master it and practice. So these are the more examples. Okay. And that's all our topic for today. Thank you for listening, students, and God bless.